Okay, and our final speaker today is Jhalok, Ronjan, Talukdar.
Good morning, everyone. So I'm going to talk about association between fat and frailty. So this study is in progress. So I will appreciate any feedback from you. So for this study, I'm working with Dr. Alexander Mayhew and then Dr. Lauren Griffith. Okay, so what is frailty? So we can simply define frailty as multifaceted vulnerability, including different kind of health aspect like physical, cognitive, social, and psychological deficiencies. So what does that mean? So if someone has frailty, then they are more susceptible to negative health outcomes. And if we actually give them early intervention, it can actually improve their quality of life and reduce cost of care. So when we are looking at this literature, and then we notice that there are studies which actually are trying to understand body fat and effect of body fat on different kind of health outcomes. But there was lack of studies which was actually trying to understand how the effect of body fat on frailty. And when we was thinking about this, and we was thinking maybe different fat have different effects on frailty. That is why we thought okay, we should actually study specific types of fat instead of fat altogether. So that's why our objective is to understand what is the association between different type of fat and frailty. And for this talk, we are specifically interested in visceral adipose tissues, which you can find actually surrounds our organs, and subcutaneous adipose tissue, which is you can find beneath the skin, and then appendicular lean mass, which is the combination of muscles in legs and arms. So for this study, we use Canadian longitudinal study on aging. This study actually tried to understand health and well-being of elderly people. They include more than 50,000 participants, but for this analysis, we use around more than 30 participants from comprehensive cohort of CLSA. And this data was collected between 2018 and 2021. And the participant of this study is community living people who are aged between 45 to 85. So our outcome is frailty is defined by many health deficits, including actually specifically 127 accumulated health deficits, including physical, psychological, cognitive, and social functioning. Some of them are binary. So for example, diabetes. Someone have diabetes or not. And some of them actually have gradient, like BMI. It could be someone has underweight, and someone could be normal weight or overweight, and different kind of obese group. This frailty index is actually validated and previously used in different studies for Canadian longitudinal study on aging. And based on our literature review, we included age, sex, education, marital status, and few other variables as our covariates. And for reporting those outcomes for descriptive statistics, we use mean and standard deviation for continuous variable, and number percentage for categorical variable. We also use graphical method to understand data visualization and understanding the trend of data. And for inferential statistics, we use linear regression. So initially, we start with unadjusted model for each fat variables, and then we adjusted with covariates, but still it is separate fat types. And then we adjusted with covariates, but we also included fat. But in this case, we use SAT and ALM. And I will talk about this in a minute, why we actually specifically included SAT and LM together, not other type of fat. And we also did sensitivity analysis using log and square root transformation of frailty index. And I will also talk about it in the next slide. So when we actually plot this frailty index, you can see that it's look like right skewed. But when we do log transformation, it's look like kind of symmetric. And there is another common method of like transforming it using square root transformation. So it's also look like similar, so like symmetric. So we wanted to use these two methods to understand how actually it changed the result if we use those two. And then we started like trying to understand what is the correlation between different kind of body composition. So there are like three types of fat I was talking about previously, and also like other kind of body composition. For example, weight, circumference, and few other variables. But for this talk, I'm mainly interested about like three fat types, so SAT, LM, and BAT. So if you look at this graph, heat map, then you can see that SAT and LM is not like correlated, you can say, but BAT is moderately correlated with LM and then SAT. That's why we actually included SAT and LM together, but we did not include like BAT with those two because they are like it is moderately correlated. This is the summary of like few selected variables. So all of them are continuous outcome except like frailty index more than 0.25. So it means if someone has actually, it is a like established cutoff point if someone has frailty or not. So for like this one, we use reported like numbers and percentage, and for other variables, we use mean and standard deviation. So if you look at this distribution, you can see that like for age, it is similar between like male and female, but female has more frailty and said fat, but male has like more fat and LM. So when we start analyzing our data with logistic linear regression, then we start with adjusted models for each of the fat variables. Then you can see that like the trend between like BAT and SAT is like they are positively correlated with frailty variable, but for LM is negatively correlated and it is also statistically significant. And then we start adjusting like the covariates. Then for LM, it actually like completely reverse. So it is now like LM is positively correlated with frailty. And then for BAT, SAT, it is also positively correlated and it is also statistically significant. So in this case, just look, we use like original scale of a frailty index, and then we transform them like a square root and then log transformation. So the result looks like similar. So it doesn't actually change the like result. And for BAT, is also still like positively correlated with frailty with original scale and log transformation and square root transformation. Then we actually like started adjusting, including on fat, like because SAT and LM is not correlated. So we wanted to add one variable more to understand what is going on if we add another SAT variable, like two fat variable together. So how is SAT now? So still it is positively correlated with frailty for like original scale and log transform and square root transform frailty index. But look at now, like for LM, it's reverse, but for like original scale, log scale, and then square root transformation. But this confidence band is very wide. And also it is not statistically significant. So that like main limitation I would say for this study is that we have like 127 health deficits in our like frailty index, but some of them actually are self-reported. So for example, diabetes and sleep duration So we think like if we actually like can actually bias our results. So this is the main limitation of our study. And if you see the result, like if we summarize all of the findings, whatever I presented previously, you can notice that BAT and SAT always like showed a positive association with frailty. But when we like for elements shows actually different trends for like different like modeling. So for example, when we start with unadjusted for any variable, so it was inversely and significantly associated with frailty. And when we actually adjusted with covariates, then it actually positively associated, and also it is statistically significant like other two fat variables. And when we add set variable in the model, then it is statistically not significant, but it is inversely associated the way it was like inversely associated when we actually add, it is just model with a frailty index. So you can see like from all of this model building and analysis that different set actually behave like differently. And maybe we also miss like few of the, because it is work in progress, maybe we also miss some of the covariates. It can show like different effect on frailty. That is why we think like it is like important to studying fat composition separately instead of just studying total fat. So this is it, because I wanted to make it a short presentation. Thank you, and you can reach me here. But I will be very happy to listen from you and get feedback so that we can improve. Thank you. Yes.
No, I'm a little confused. Of the 127 items that are in the frailty index,
Yes.
BMI is one of those items.
Yeah.
So how do you adjust then for the high correlation between BMI and various amounts of fat in various distributions? Isn't that highly correlated?
So this is highly correlated. That's why we did not include it in our model, because it is highly correlated with other fats. So
But the frailty is determined by the BMI,
yeah.
not as a problem.
So you are saying like BMI is included already here, and it is like creating problem. So like there are other variables as well, like in this model. So other like specifically there are like 4 type of health deficit we are including in this thing. So when we are seeing this correlation, the like BMI, because it is a total fat. So like we are checking like whether, that's why we did not include in the model, because it is highly correlated, and also we wanted to understand like bad set and all of these things are not in this in this frailty index. So it will be highly correlated the way you said, it will be highly correlated. So that's why we did not include in this model. Instead we use like BAT and set, because it is determined by also BMI. Yeah. Yeah. Yeah.
One of the big questions is how do they measure and document the different fat percentages? How is it measured?
Yeah.
Because as best as I can understand it, most of the validation using that standard doesn't have a good or standardized way of measuring. Is there a lab possible?
Okay.
The other part of it was in terms of interpreting your data, if you're purely basing it on a number based of your academic mass, something who's a 4-foot tall woman compared to a 6.5-foot tall man are going to have vastly different numbers, but the way you interpret their mass might be different based on the height of the weight. So this will adjust everything, like adjust the values themselves.
I think like so this is an issue with, I think, mostly with BMI, because like BMI took consideration of those things, but the way BAT and SAT are measured is using, like you said, mentioned that DEXA images. So yeah, I have to go like I have to also study like what is the like problem with DEXA measures, but it was measured using DEXA scan images. So yeah, but if there is problem, you have to like figure out. But it is the data I am just using because I try to understand what is available right now. But it is a good point. I'll also look at this. Like, is there any like problem with like using this information, or I should use another sources maybe? Yeah, thank you. Yeah. Yes, please. Yeah.
Do you know, did you see, or was there a confounder in particular that really contributed to then aligning the associations to match that association that you saw with the other context? Or just wondering if there's a variable or two in particular that kind of drives a lot of that?
Yeah, I think like when I was modeling this thing, like when I actually like did unadjusted analysis, the like model was not well fit then. But when we actually added ALM with this one, it was fitted well. I think like so shared variable could be like unimportant predictor or like or factors to actually drive this relationship. So, but for me, just unadjusted analysis doesn't make much sense because you have to adjust all of these things. And maybe like we have to look at the look at other coverts also. So we'll do that also. And we have also other plan like adjusting, like Dr. Miss Libin was talking about like BMI and other variables. We'll see like if we take residuals, how they will change. So we'll do also like more analysis for this thing, but it is not final yet. Thank you. Thanks.
All right, I'd like to thank all the speakers for sharing their great research and for keeping us on time. You'll all be happy to know that lunch is next, so please enjoy the rest of your day.